Hello, welcome back to our last section of college algebra. This is section 5.1, Systems of Linear Equations, and in this section we'll talk about linear systems, what a system is and how to check a solution to a system, and we'll also talk about the substitution method and the elimination method for solving systems, and then we'll talk about some special systems that have unusual solution sets. Here we go. First of all, what do we mean by a linear system? Well, a set of equations that is considered simultaneously is called a system of equations. And the solutions to a system must satisfy every equation in the system. In other words, the solution of a system has to check in every equation in the system. If all the equations in a system are linear, then we call it a system of linear equations, or for short we just say linear system. In this section we will only be working with systems of two equations. Although you can have many equations, we will only have two at a time here. For a system of two linear equations, there are three different outcomes. Remember, each equation in the system would graph a line. It might be that the two lines cross at exactly one point. In this case, these two equations make up our system, and the solution to the system is the ordered pair 0, -2. Another possibility is that the two equations graph parallel lines, as you see here. In a case like this, the system has no solution because the lines will never cross. The third possibility is that the two equations actually graph the same line. In this case, not every ordered pair is a solution, but there is an infinite supply of solutions. We say that this system has infinitely many solutions, and I'll tell you how to give a more exact solution when we get to the end of the section. Now we're almost ready to start solving systems, and we're going to learn, like I said, two methods of solving, and the first one is called the substitution method. Now I'm going to go ahead and give you the steps first, but just know that they won't make a lot of sense till after we've been through the process at least one time. But here we go. To solve a system by the substitution method, solve one of the equations for one of its variables. And you can solve either equation for either variable, and the way that we choose is just whichever one's easiest for us to work with. And then substitute that expression into the other equation, and this will eliminate one of the variables. Then you're going to solve for the remaining variable, substitute that value back into the equation from step 1, and the solution is the ordered pair. Now that we have the steps for solving a system by the substitution method, let's do an example together. This is example 1, and it says solve the system 3x plus 2y equals 11 and negative x plus y equals 3. Now this system is just perfect for the substitution method because it's going to be very easy for us to solve this second equation for y. So let's plan on isolating the y in the second equation. That means we will take this negative x and move it to the right side, giving us the equation y equals x plus 3. Now we can take this x plus 3 and substitute it into the other equation. You see, because this says y equals x plus 3, we'll put x plus 3 in place of the y. So 3x plus 2y becomes 3x plus 2 times this expression, and that equals 11. You see how that eliminated the y variable, and now we can distribute the 2 and combine like terms and solve. So now I'll subtract 6 from both sides and divide both sides by 5, and we find out x equals 1. Okay, well that's half of our solution. Now we need a y coordinate to go with that. And so let's take our 1 and plug it back into the first equation that we solved for y. And y now equals x plus 3, which we now know is 1 plus 3. And so y equals 4. And so our solution is the ordered pair 1, 4. Now remember that ordered pairs always have to go in the order x first and then y. And remember that ordered pairs are supposed to be in parentheses. So when they ask you in MyLabs Plus for the solution to your system, you need to give the solution as an ordered pair in parentheses with the coordinates separated by a comma. That ordered pair will go inside a pair of curly braces. Now, before we get too sure that this is the solution, we should check our work because it's very easy to make a little addition or multiplication mistake on these problems. So let's plug 1, 4 into the top equation, and the left side should equal the right side. So 3x plus 2y becomes 3 times 1 plus 2 times 4, and that's supposed to add up to 11. And it's going to be 3 plus 8 equals 11, and that's true. And now let's plug 1, 4 into the second equation. So it's going to be negative 1 plus 4 equals 3, and that's also true. And so we can be sure that 1, 4 is the right answer. And if you could graph these two lines, if you take the trouble to solve them both for y and graph them, you'd see that they cross at the point 1, 4, and that's the only place they can cross. So there can only be one ordered pair solution to a system of two linear equations. Now this is when you can try on your own if you would like to pause the video. Here is a system that you can solve using the substitution method. So give it a try and then we'll go through it together. Okay, now let's go through it together. This second equation is already solved for x. So all we have to do is take the expression that x is equal to and plug it into the first equation. So instead of x minus 5y equals 8, we'll have 6y minus 5y equals 8. You see the 6y takes the place of the x because it says x equals 6y. Okay, now combining like terms, 6y minus 5y is 1y. So now we have y equals 8. And that's 1/2 of our ordered pair solution. So now take the y equals 8 and plug it into the other equation, and we'll have x equals 6 times y, which is x equals 6 times 8, so x equals 48. So remember, our ordered pair solution has to be x comma y. So our solution is 48 comma 8, and that should be in a pair of curly braces. And now let's check our ordered pair solution in both equations and make sure that it's correct. So we'll plug 48 comma 8 into the top equation. That will give us 48 minus 5 times 8, and that's supposed to equal 8. So let's see, 5 times 8 is 40. 48 minus 40 is 8, which is equal to the right side, so that looks good. And now let's plug into the second equation. So that will say 48 equals 6 times 8, and that is also true. So it looks like 48 comma 8 is the correct solution here. And now let's talk about the elimination method. So I'm going to give you some steps for solving by the elimination method, and then we'll do a couple of examples like we just did for substitution method. So to solve by the elimination method, we're going to multiply either equation, or in some cases both equations, by any multiplier necessary to achieve equal but opposite coefficients on one of the variables. After we get the equal but opposite coefficients, we'll add the two equations together. That will eliminate one of the variables. We will solve for the remaining variable and then substitute that value back into either original equation to find the other variable. And just like we saw with the substitution method, this will make more sense once we've done it once or twice together. So here we have example 2. We're going to solve the system 3x minus 4y equals 1 and 2x plus 3y equals 12. Now notice that none of the variables in either equation has a coefficient of 1. That means in order to solve one of these equations for one of these variables, we would end up dividing by its coefficient, which would create a fraction, which would make the substitution method slightly difficult to use. So this is a perfect system to use the elimination method on. So what our goal is to multiply the top equation and the bottom equation by whatever it takes so that two of the coefficients are equal but opposite. You could make a really good case for multiplying the top equation by 3 and the bottom equation by 4. That way you'd have negative 12y and positive 12y, and that would work to eliminate the y's. But just because it's slightly more difficult, I'm going to show you how to eliminate the x's. It's not really harder, it's just that I want to show you the trick. So remember that we need the coefficients to be equal but opposite. And here they're both positive, so I'm going to have to choose to multiply one of them by something negative. Now you got to ask yourself, what is a number that's a common multiple of both 3 and 2? And you say, well, 6 is a common multiple of 3 and 2. Great, so let's multiply the top equation by 2, because that way we can get our 6x. Now what are we going to have to multiply the bottom equation by so that we can have a negative 6x down here? Well, we need to multiply the bottom equation by negative 3. So here are our two equations. We're going to multiply the top equation by 2, multiply everything by 2, and multiply the bottom equation by negative 3. And watch what happens here. 2 times 3x will be 6x, 2 times 4y will be 8y, and 2 times 1 will be 2. And in the bottom equation, negative 3 times 2x is negative 6x, negative 3 times 3y is negative 9y, and negative 3 times 12 is negative 36. Now notice that we have equal but opposite coefficients here on our x. We have a positive 6x and a negative 6x. So now we will add these two equations together, and the x's will add up to 0, which is what we want. And now the y's are going to make negative 17y, and the right side is going to be negative 34. Now we divide both sides by negative 17, and we end up with y equals 2, which is half of our solution, but remember the solution is an ordered pair. So now I have to find x. So now we take our 2 and we plug it into either equation. Either one will work. You can just choose whichever one looks easiest to you to use. So I'm going to choose the top one. So I'm going to say 3x minus 4 times y, which now I know that y is 2. So 3x minus 4 times 2 equals 1. Now 4 times 2 is 8, so I have 3x minus 8 equals 1. Add 8 to both sides and divide both sides by 3, and we find out that x is 3. So our solution is 3, 2. And again, remember that it always has to go x, y. It doesn't matter which number you found first, but when you give your solution, the x always has to come first and the y comes second. So 3, 2. Now let's check. So we should plug the x and the y into each equation and make sure that they both work. So 3 times 3 minus 4 times 2 equals 1. See, 3x minus 4y. And that's going to give us 9 minus 8 equals 1, which we know is true. And let's try it in the second equation. 2 times 3 plus 3 times 2 equals 12. That says 6 plus 6 equals 12, which again is true. And so 3, 2 is the solution to our system. Now here is a system that involves some fractions, so I wanted us to be sure and take a look at this one. And I think when you have one like this, the easiest thing to do is not wrestle with the fractions, but instead multiply the denominators away, the same way we did when we were solving linear equations that involved fractions. So what I'm going to do before I try to worry about elimination method or substitution method is I'm going to multiply the top equation by 6. See, that's going to cancel out our denominators. So here I'm going to multiply both sides of the top equation by 6, and that's going to give us 3x plus 2y equals 24. And now on the bottom equation, let's multiply everything by 2. And these 2's will cancel, and that will leave us 3x. And these 2's will cancel, and that will leave us 3y. And then nothing cancels over here, so that gives us 30. Okay, now we've got a system of equations without any fractions, and notice that the x coefficients are both positive 3. So we have our coefficient that we need, but we need one of them to be negative, so let's multiply the bottom equation by negative 1. That's going to give us still 3x plus 2y equals 24 for the top equation, but for the bottom equation, negative 3x minus 3y equals negative 30. Now we'll add these together. The x's will add up to 0, the y's will add up to negative 1y, and the right side will add up to negative 6. So if negative y equals negative 6, then positive y equals positive 6. And now let's substitute that 6 back into really any of our equations, but I'm going to choose to substitute it back into this equation from which I've already eliminated the denominators. I just think that'll be a little easier to handle. So I've got 3x plus 2 times 6 equals 24. So of course 2 times 6 is 12. Now subtract 12 from both sides and 3x equals 12, so that means x equals 4. And so our ordered pair solution is 4, 6. Now we've learned two methods for solving a linear system. We have the substitution method and the elimination method. Some problems will lend themselves to one method, while other problems will lend themselves to the other method. So you need to know how to recognize the best, easiest to use method on each problem. The substitution method is the best one to use if one of the equations is already solved for one of the variables. You can also choose to use the substitution method if either equation has a variable with a coefficient of 1. Other than that, you can choose the method you like best. The elimination method is frequently the favorite because it's very straightforward. There seems to be a lot less solving going on with the elimination method. The only time you must use a particular method is if the directions specify and you're being graded on showing your work. Otherwise, if you're not showing your work, you really can choose whichever method you think is easiest for you in that moment. So now let's look at a couple of systems together and we'll try to decide which method we think is the easiest. This system is not in the same form that we've seen the other two in. This one happens to have the constants on the left, so the first thing I would do is move those constants to the right. And now I would look at my coefficients and I see that I have a 5 and a 4 and a 4 and a 5, and none of them are 1s. So I'm going to say substitution is out here. And so we want to use the elimination method. But now which variable should we eliminate? Here I have 5x and 4x. Okay, I can make these into 20s, but I'm going to have to multiply one of the equations by a negative because I don't need them to both be positive. Here, I have a positive and a negative already built in, so I think I'll go ahead and eliminate the y variable. Let's shoot for 20y and negative 20y. So let's multiply the top equation by 5. That's going to give us 25x plus 20y equals negative 10. And let's multiply the bottom equation by 4, and that's going to give us 16x minus 20y equals 92. So you can see now we have what we wanted. We have positive 20y and negative 20y. So now let's add our two equations together. 25x plus 16x is going to give us positive 41x. The y terms add up to 0. And on the right side, negative 10 plus 92 is going to be positive 82. Now divide both sides by 41. And we have x equals 2. Now we take our 2 and plug it back into either equation. So I'm just choosing the top equation, and notice that I've kept my negative 2 moved over to the right side. So 5 times 2 is 10, and subtract 10 from both sides. That gives us 4y equals negative 12, and divide both sides by 4, and y equals negative 3. So our solution is 2, negative 3. And if you wanted to just check that by running it through the second equation real fast, it wouldn't be hard to do. 4 times 2 is 8. Negative 5 times negative 3 is positive 15. So 8 plus 15 is 23, and 23 minus 23 is 0. So it looks like the 2, negative 3 does check for us. Here is another system. This one says 8x minus 10y equals negative 22 and 3x plus y equals 6. Notice that in this system, one of the coefficients is a 1. That means that the substitution method can be used here if you so choose. The elimination method is just as easy here if you happen to prefer that one. So I'm going to go ahead and solve this one using the substitution method, but then I'm also going to show you how to use the elimination method, and you can decide which one you like best. Now we're using substitution method first, so let's start out by isolating this y. So I'll take my second equation and I'll move this 3x over to the right side. That's going to give us y equals negative 3x plus 6. Now remember the substitution method, we substitute this expression in place of the y in the other equation. So now I'm going to have 8x minus 10 times negative 3x plus 6 equals negative 22, like this. Okay, now the y is eliminated and all we have left is x. Now I'm going to distribute the negative 10. That's going to give us 8x plus 30x minus 60 equals negative 22. Now we'll combine like terms. 8x plus 30x is 38x. Now we'll add 60 to both sides. So on the right side we'd have 60 minus 22, which is 38. Now we have 38x equals 38. Let's divide both sides by 38, and we have x equals 1. Okay, now we take our 1, we substitute it back into our solved equation, and we have y equals negative 3 times 1 plus 6. Negative 3 plus 6 is positive 3. So our ordered pair solution is 1, 3. Okay, now let's try it by the elimination method, and you can decide which you prefer. To do this by elimination, the easiest thing to do would be to create a coefficient of 10 here. So I'll leave the top equation unchanged, and the bottom equation I just need to multiply everything by 10. That's going to give us, for the top, 8x minus 10y equals negative 22, and for the bottom, 30x plus 10y equals 60. Now add the two equations together. You get 38x equals 38, and from there it's the same as the other method. Divide both sides by 38, x equals 1. Now take your 1 and substitute it back into either equation. I'm going to substitute it into the bottom equation so that I don't have a y coefficient to deal with. That gives me 3 times 1 plus y equals 6. That means 3 plus y equals 6. Now subtract 3 from both sides, and y equals 3. And we already had x equals 1, so our solution again is 1, 3. So sometimes substitution might be better, and sometimes elimination might be better, and sometimes it just might be totally your choice as to which one you personally prefer. Now we're going to talk about some of those special systems that we mentioned way back at the beginning of the section. If you're solving and both variables disappear in the solving process, and you're left with a false statement such as 5 equals 0, you have found a system with no solution. In other words, if you graphed the two equations that you're working with, you would see that they graph parallel lines, and because the lines are parallel, they never cross, and because they never cross, there's no solution. Remember, the solution is the point of intersection. A system like this is called an inconsistent system because there is no ordered pair that is on both lines. And the solution, therefore, is the empty set. On the other hand, if both variables disappear in the solving process and you're left with a true statement such as 0 equals 0, in this case you found a system with infinitely many solutions. What's happening here is that your two equations actually are graphing the same line. So any point that is on one of the lines is also on the other line. Therefore, any ordered pair that works for one equation will also work for the other. Now, stating the solution to these is a little trickier than the others because you can't just say that all ordered pairs are a solution. And you need to be a little more specific than infinitely many solutions. You can't just say, well, there's a whole bunch of solutions. You have to be a little more specific. So the solution is given in the form of an ordered pair where one of the equations has been solved for one of the variables. and the variable you should solve for will have to be specified in the instructions. They'll either tell you write it in terms of x or write it in terms of y. So we're going to see one like that in just a few minutes. Now here's example 3. This says solve the system 3x minus 2y equals 4 and negative 6x plus 4y equals 7. Notice that none of the coefficients are 1s, so the substitution method is out here. Let's go for the elimination method, and I'm going to choose to make my x coefficients the same but opposite. Now the bottom one is already negative 6, and so I want the top coefficient for the x, and so I want the top x coefficient to be positive 6. So I'll just multiply the top equation by 2. Here I go, I'm going to multiply this top equation by 2, and that's going to give me 6x minus 4y equals 8, and the other equation will leave unchanged. And now we'll add these two together, and the x's will add up to 0, but look, also the y's add up to 0, so the entire left side is 0, but the right side is 15. So this is an impossible situation. Therefore, this system of equations has no solution. So you could say that the solution is the empty set. That would just be another way of saying the same thing. And now let's look at this example. This is example 4. We have 8x minus 2y equals negative 4 and negative 4x plus y equals 2. So even though we could use the substitution method here, let's again use the elimination method because I see it would be so easy to get rid of the x term by multiplying this equation by 2. So I'm going to leave the top equation the same, and I'm going to multiply the bottom equation by 2, and that's going to give us, for the bottom equation, negative 8x plus 2y equals 4. And now when I add up the left sides, I get 0, and also when I add up the right sides, I get 0. That's telling me that actually these two equations, although they look different, they're really the same equation. So they have all the same solutions, and in this case, there's an infinite number of solutions. To specify which ordered pairs are solutions, what we can do is take one of our equations, and in this case, I'll choose this one because it's simpler. And I'm going to solve it for y, so I'm going to move the 4x to the right side. And so I see that y equals 4x plus 2. That means the solution can be written this way. Any x value you want to use, and the y value that goes with it can be found by calculating 4x plus 2. So this is a way of stating the solution in terms of x. We also could choose to state the solution in terms of y. To do that, we would need to actually solve for x. So let's isolate the x here, and I think the easiest way to do it is to move this 2 to the left and move this negative 4x to the right. That way we can have a positive coefficient on our 4. And now I have to divide both sides by 4. And so my x value can be calculated by plugging in a y and subtracting 2 and then dividing that by 4. Now we can state that solution by using this expression for x and then saying that you can choose your y. So you can either choose your x and then calculate y, or you can choose your y and then calculate x. And the way you decide which way to state your solution will be determined by the instructions. They'll either say state your solution in terms of x, which means that they want you to eliminate all the y values from the solution, or they'll say state your solution in terms of y, which means they want you to eliminate the x values.